Hey guys, welcome to yet another interesting and informative video by Simplilearn. In today's video, we're going to be learning all about doubly linked list in C. But before we begin, if you haven't subscribed to our channel already, make sure to hit the subscribe button and the bell icon to never miss an update. So now, without any further delay, let's begin. This session will help you understand what a doubly linked list is in C. Moving ahead, let's understand the memory representation of a doubly linked list. Later, let's look at the syntax and finally operations performed on a doubly linked list. Now, let's begin by understanding what a doubly linked list is in C. A doubly linked list is complex as compared to a singly linked list. In the doubly linked list, the traversal happens in two ways, forward and backward direction, and each node consists of data and address of the previous and next node. As it is clear from the above diagram that the first node's previous is pointing to null, which means no more nodes before it. And its next part is holding the address of its next node, that is the address of second node. Similarly, second node previous is holding the address of the first node and next is holding the address of the third node. Followed by that, the third node's next is pointing to the null because no other node after it, and its previous is holding the address of the second node. This will continue as many nodes are in the doubly linked list. And the elements are located at some random location in the memory. For example, as you can see, if the first element is inserted at the location 2000, then the next element would be located at 2016 and then at the next free location and so on. Moving ahead, let's have a look at the doubly linked list memory representation. Let's consider one example and understand the representation of a doubly linked list. So, consider three elements to be inserted into the list, where each node consists of data part and address part of previous and next node, and it is stored at some address 2000, 2016, and 2022. The address of the first node is stored in the special node called head node. As I discussed before, the first node's previous is pointing to null because there are no nodes before it. And the last node next is pointing to the null because there are no nodes after it. Every node in a linked list is connected in two ways from forward and backward direction with the other through the pointers called previous and next that points to the address of its previous and next node. It is represented by the arrows in this diagram. For example, so let our elements to be inserted be 10, 20 and 30. And the address of the first node is stored in the head node. And the next part of the first node, that is this, is holding the address of the next node, that is 2016. And its previous is pointing to the null. Similarly, the second node is holding the address of the third node, that is 2022. And its previous is holding the address of its first node, that is 2000. Whereas the third node, the previous is holding the address of its previous node, that is 2016, and its next is pointing to the null. And in this way, they are linked together. Up next, we have the syntax of a doubly linked list. A doubly linked list consists of an extra pointer compared to a singly linked list. So, the syntax starts with a struct keyword followed by structure name called node. Then we have the variables declared, that is data, and struct node asterisk next and previous, a pointer variables pointing to an element of a structure node. So with this, let's try to execute a simple doubly linked list program to understand in a better way. So from this program, we are going to create 4 nodes and insert the elements into it. So we have previously discussed this syntax of a doubly linked list. So here we have a previous and next pointer variable. So moving ahead, we'll see that we have a head node and we are creating first, second, and third and fourth node. So initially those are null, so they are initialized to null, and for creating we need to allocate the memory for it, right? To create a node we need to create memory for it. For that we are using malloc function to allocate memory for the node first, second, third, and fourth. And once we create memory, we are going to assign the values to it. So here the values are 10, 20, 30, and 40. So these values are assigned in the first data part, in the second data part, third data part, and the fourth data part of every node. And once after assigning, we need to link these nodes together. So for that, we have the first next part is assigned to the second. That means it holds of the second element. And its previous is assigned to null because there are no node before it. And the second node's next part is assigned to third, and its previous is assigned to first. Similarly, the third next is assigned to fourth, and its previous is assigned to the second node. And the last node, that is fourth node's next, is null because there are no node after it, and its previous is assigned to third. That means it holds the address of a third element. And now the first is assigned to head. That means the address of first node is holding in the head node. And finally displays the first. So this display function we have to display all the element in a doubly linked list. So this will So as you can see, here we got the output. The doubly linked list elements are 10, 20, 30, and 40. Okay, so now let us move on to the operations on a doubly linked list. First, we have insertion operation. Next, deletion operation. And finally, traversal operation. So let's understand them in detail. Under insertion operation, we have insertion at beginning. So basically, we insert the element at the beginning of the element list. Next, insertion at end. That means it inserts the element at the end of the element list. And lastly, insertion after specified node. That means it inserts the element after some specified node. So now let's run the program and understand these operations practically. So using insertion operation, we are going to execute a simple program. So we have previously discussed that we have two pointer variables, that is previous and next, that is pointing to its previous and the next node. And first let's discuss the insertion at beginning operation. So basically we are going to insert a node at the beginning of a linked list. So for that we are creating a new node and allocating memory for it using malloc function. Once creating the memory, the new data part, the new node's data part is holding the new data. And the next is pointing to the head. And its previous is pointing to the null because there are no nodes after it. So if head is not equal to null, that means head's previous is equal to new. And now new is assigned to the head. So it's simple. Now the head is holding the address of a new node. Next, coming to the insertion at end. So here again, we are creating a new node, allocating memory for it, and that new data is holding the new data, and its next is pointing to null because there are no more nodes after it. And we are creating a temporary variable where true hold the address of a head. So now if the head is equal to null, that means new previous is pointing to the null, and new is assigned to the head and return. While the temp next, if it is not equal to null, then the temp next is assigned to the temp variable, and the new is assigned to the temp next, and temp is assigned to the new previous. So now the last node is inserted. Now coming to the insertion after node, that means inserting in between of two nodes. So if previous node is equal to null, that means the given previous node cannot be null. For that, we are creating again a new node and allocating memory for it using malloc function, and its new data is holding the new node's data part is holding the new data, and the new node next part is assigned to the previous node's next, and we're just changing the addresses. So now here previous node next is pointing to the new, and the previous node is now assigned to the new previous. So if new next is not equal to null, that means new next previous is equal to new. So coming to the display here, while node is not equal to null, it will print all the node data till it finds the null. And here in the main function, we are creating a head which is initialized to null initially, and when the control comes to the insertion at end, it will print a value 4. And next, when it encounters the insertion at beginning function, that means it will insert 2 in front of the element 4. And again, insertion at beginning, so it insert the element 1 in front of element 2. And similarly, insertion at end, that means it will print element 5 after the element 4. And insertion after node head next, that means it will insert the element after the element 2. So now let's try to execute and run the program. So as you can see, the elements are listed in a proper way. That means we have the elements 1, 2, 3, 4 and 5. Followed by that, we have deletion operation to delete from the beginning, delete from the end, and delete after specific node. So now let's run a program. So now we are going to perform the deletion operation. So for that, we have a function called deletion node. So basically we are going to delete a node from a list. So first, it checks the condition if head is equal to null or node delete is equal to null. That means a node to be deleted is also equal to null, then it will return. That means the deletion is not possible. Next, it checks the next condition if head is equal to node delete. That means if a node to be deleted is our first node, then head is equal to head nodes next. That means the head node next is assigned to the head. Next condition, if node delete next is not equal to null, that means if it is not the last node, that means point the previous next node to the node delete previous. And finally, if node delete previous is not equal to null, that means if the node to be deleted is not the first node, then point the next previous to the delete node delete next. And finally, we are going to free up the memory space for that node. And coming to the main function, where we have print function, after deleting an element, it's gonna delete the node. So here after the head next 1, 2, 3, 4th. So after the 4th node, it's gonna delete the 5th element. That is, it will delete the last element 5. So let's check the output. So as you can see, after deleting an element, so our previously inserted elements were 1, 2, 3, 4 and 5. And after deleting, now the element 5th is deleted. Finally, we have traversal operation. In this operation, we visit each and every node at least once, maybe to display all the data elements or to perform operations on it. So let's understand it practically. So here we are going to perform a traversal operation. That means it actually visits each and every node at least once and display them. So here, using a display function, we are going to display all the elements that are present in a linked list. So now let's try to execute and run it. So as you can see, first The inserted elements were 1, 2, 3, 4 and 5, and after deleting an element, now the elements are 1, 2, 3 and 4. That means the fifth element got deleted, and now the final list of elements are 1, 2, 3 and 4. I hope you got a clear understanding of how to perform insertion, deletion and traversal operations in doubly linked list. So with this, we have come to the end of this session on a doubly linked list in C. I hope this session was informative and interesting. If you have any queries regarding any of the topics covered in this session, or if you require the resources like PPT, core documents or anything, then please feel free to let us know in the comment section below. And our team of experts will be happier to resolve all your queries at the earliest. Until next time, thank you, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.